Hi Maharshi, what do you do? Like, can you give a brief introduction about the SME?
Yes. Well, my name is Maharshi, and I'm part of the team at Space Structures, which is a Berlin-based space company. Space Structures is an independent engineering firm that specializes in the development, manufacturing, and verification of advanced metal and fiber reinforced polymer structures for space applications and in the field of structural mechanics and thermal engineering. Today, I would like to show you some cool stuff that have potential applications in the space as well as non-space domain.
So let's move on to the next question. Can you explain and describe your product?
So when dealing with fiber reinforced polymer structures, a complex and expensive industrial equipment and tooling is needed to shape the final product. According to our market research and experience, modular molds that can be used for different geometries, parts, or subassembly are the key innovation. Now, the goal here was to exploit the disruptive innovation of stereolithography, which is commonly known as SLA, which uses a photochemical process to form polymers. This technology is the best to obtain parts with strict tolerances without post-processing, which was an important requirement for us. Complicated geometry could also be made, which subtractive technologies are not really capable of. We had some complicated and complex design choices that we had to make in terms of designing our mold, and using additive manufacturing that was easily realized. And finally, another important benefit will be the reduction of lead time and costs. And once the mold has been designed and manufactured, modular mold components could be easily printed or overnight in-house.
That's a smart way of using additive manufacturing, using modular fixturing with AM. It's a good application. Okay. What do you expect from additive manufacturing?
So one of the most important features we found that was important was to enable the manufacturing of design that is not manufacturable by other techniques. Like I mentioned, complex features which could not be realized using subtractive techniques, and it was easily doable using 3D printing, and also to include functionality or multi-material design, something that can be difficult to achieve with other manufacturing techniques, of course.
So what challenges do you expect in the beginning of the project, and what challenges during the project?
So the technical challenge was to design, manufacture, and integrate 3D printed modular mold components with sufficient geometrical accuracy and manufacturing repeatability that would eventually be combined with the milled main molds. And this design needed to guarantee a good degree of modularity to justify the costs of this approach. The parameters for additive manufacturing were important here because sufficient tolerance precision was also required. So another relevant challenge we faced was the right selection of material for the mold. The fittings needed to be chemically compatible with the mold, and no thermal expansion was to be had during the process. And also with AMable support, we were able to have an extensive questionnaire for each criterion and evaluate the feasibility of each of these challenges accordingly.
Yeah, great. So which AMable services did you choose and why?
Space Structures has chosen the AM Decision Support or AM Wizard service. The reason behind this was so that we could have faster and more efficient design trade-offs with respect to the mold design.
Okay. So how has AMable helped you until now, and how have you benefited from the AMable support in the project?
We had some really good talks and knowledge exchange. On the SME side, there's usually not a large group of people dealing with one topic or one project. And the smaller you are as an SME, it is very likely that only one person builds up the specific knowledge for a project. And with AMable support, we were able to not only exchange ideas, but also get the right questions asked.
Yeah. So when will your product be available on the market?
So the main aim of this project was to develop an auxiliary tool to develop products for the market later. And so this auxiliary tool was developed as part of this project, and that would be used to make products for other projects on a project by project basis. So it depends on future projects, basically.
So how has your experience with AMable project been like?
It has been a great opportunity to address such a small project in a funded environment. Typically, when you do it as a company internal project, customer projects tend to take priority, and it becomes difficult to maintain momentum. AMable feasibility experiments tend to be like short sprints. So from the get-go, you have to dive in with full commitment, and you also have the support of the people to get it done. And I think that is really important when trying to finish a project in such a short time frame. When we started out, our knowledge about the topic was fairly low. But over the time period of the project, we got to learn a lot, especially with feedback and support from AMable.
I think that's all from me.